Holding all other things constant in a sample, there are three things that could impact the width of your confidence interval. First, your confidence interval's width will be impacted by your confidence level, whether you're using 90%, 95%, 99%, for example, would impact the width of your interval. Second, your sample size will impact the confidence interval's width. And lastly, if you're doing a quantitative data set, the standard deviation of the population would impact the width of your confidence interval. Very briefly then, let's take a look at each of these. So first of all, holding all other things constant, a bigger confidence level will create a wider confidence interval. You could say, for example, that you are 100% confident that the true value of your population parameter is somewhere between negative infinity and infinity. So notice in this kind of simple logical sentence, the 100% is the confidence level. And it's very high. It's as high as you could possibly get with a confidence level, 100%. This is not an actual confidence level we would ever have in reality. And the confidence interval that we have is the interval negative infinity up to positive infinity. It's as high as a confidence interval could possibly be. It's infinitely wide, right? It's huge. So very high confidence level of 100% went with a very wide confidence interval. Likewise, logical understanding, if you went out and you collected a sample statistic and you wanted to make a conclusion that the true value of the population parameter fell somewhere, a little tiny bit below that up to a little tiny bit above that. If you wanted to have a conclusion that had a very small, narrow confidence interval, then your confidence level that accompanied that would be very small. You would not be very confident that that tiny little interval captured the true value of the population parameter. It's such a small interval that you wouldn't have a lot of confidence that you actually captured the true value of the population parameter. Second, holding all other things constant, a bigger sample size will create a narrower confidence interval. And again, let's just take away the mathematics of this, which you can look at in the book. We just want to kind of think about this logically and why this just makes sense. If you go out in the world and you collect a sample, you would then go through your statistical procedures and create your confidence interval to try to estimate the true value of the population parameter based on your sample information. Well, if you are creating a confidence interval based on your sample information, obviously a small sample is less information than a big sample, assuming, of course, that they're both good representative samples. A small sample will give you less information than a big sample. So if you have a bigger sample, you could have a confidence interval that is more narrow around the observed sample statistic. Okay, so again, let's recall what a confidence interval is. When you go out and you collect a sample, you get your observed sample statistic. I'm just going to go ahead and put that right here on my number line. Let's say you go out and you collect a small sample, and there's your sample statistic. Let's say somebody else goes out into the same population and collects a big sample, and they get exactly the same sample statistic. Okay, so they're both located on the number line in exactly the same place. The person who did the small sample has less information about the population. They have a smaller sample, which gives less information. So when they create their confidence interval, they're going to have a big margin of error. Remember, margin of error is that distance from the sample statistic to the outer edge of their confidence interval. They have more error than the person who collected a big sample. A person who was in the same population doing their sampling technique in the same manner would have a smaller margin of error because they had a bigger sample that gave them more information about the population. Big sample, smaller margin of error, narrower confidence interval. Small sample, bigger margin of error, wider confidence interval. That's just the logical understanding of why that makes sense. Again, to understand that mathematically, please go ahead and read through the book and such. Lastly, then, holding all other things constant, a quantitative data set that has a larger standard deviation is going to produce a larger confidence interval. So again, this just logically makes sense. If you have a population of quantitative data and that data is all spread out in value, has a lot of spread, very low values, very high values, then when you create your confidence interval to try to give the true value of the population parameter, it makes sense that your confidence interval would be spread out. So there's a lot of variety in the data. You are going to have a wider interval to try to guesstimate that true value of the population parameter. Whereas if you have a population of quantitative data that is, narrowly spread out, that is all very similar to one another, your confidence interval is going to be narrow as well, because that narrow interval is more likely to capture the true value of the population parameter.